Okay, let's see example 6.1. Okay. Here is planar 2 rotation robot. So uh, there is two-link planar robot. This one is two-link planar robot. So in here, the length, first length is 1 meter and 1 meter, and there is zeta 1, zeta 2. So from here to B frame, here is end effector. So the goal is find the joint angle and the vector plane corresponding zeta 1 30 degree and 90 degree. The initial guess is 0 and 30 degree. After one Newton-Raphson iteration, the calculated joint angle is 34 degree, 79 degree. The square axis is takes the initial frame to the goal frame in a curved dash line. So this script means there was initial guess 0.0 degree and 30 degree. So here is 0 degree and there is 30 degree. From here, we learned one Newton-Raphson iteration, one iteration. Then they found this angle. So actually the goal position is like this, 90 degree, 30 degree and 90 degree. But the goal position is here, but one iteration found here. So very closely found just one iteration. So that is very good. So actually using the square axis here, by rotating the two R robot, they make this kind of configuration from here, from this initial guess to this configuration. So let's see the process about this one. Actually, the body Jacobian, we applied body Jacobian schematics like this. So each link is 1 meter. Find the joint angle. Yeah. Okay. Actually, we already know the solution. Actually, in this angle, the homogeneous transformation become like this, and as you can see, the position x value and y value is same with the goal position. So from this we can know actually the this one is goal solution. Actually, the solution about this position. So actually the inverse kinematic solution is here, but we want to check how to find the solution using Newton-Raphson method. So firstly, we have to know about this M configuration. This one is homogeneous transformation matrix in the zero configuration. And there is B1, B2. This one is body screw. So body screw is omega. So because this one is rotating by z-axis, so it becomes 001, 001, and this V value can be calculated Q cross V. So this one, yeah, okay. Then the first initial guess is 0 and 30 degree, and then we specified the epsilon value about omega equal 0.001, and epsilon value about v as 0, 10 minus 4 square. So determination method iterate illustrated in this table. So in the first iteration, they reached this, and so after one iteration, they found this solution. And second iteration, it becomes more close. And third iteration, it becomes 30 and 90 degrees. So they found the solution. And in this angle, they specified the XY position. And in the case, there is twist. Twist is in here because planar case, because of this is the planar case. Omega z x y, omega xy is equal 0, so we ignored here, and vz is ignored here. So only 3 value is indicated. In here, as you can see, the twist is written like this. So let's in this example, we can know even 3 iteration we can reach the goal position. So this is very good way to find the inverse kinematic solution. So let's do this with the modern robotics library. So we import MR modern robotics library, and then I capture the example 6.1, and I indicate here. And this example, each link length is 1, and want to find angle that XY position is like this. So M value and B list, body skew list is given like this, and TSD. So this one is goal configuration. Goal configuration is given like this. So XY position here, and this one is rotation matrix information. So this information is given in the problem. And this one is theta list initial guess value, and this one is epsilon omega, and epsilon v. So using inverse kinematics body function in modern robotics library, we can run this one. Okay. Here, the iteration success. So this one is true, and the theta solution is like this. So if you calculate pi over 6 and pi over 2, this one is 30 degree and 90 degree is almost same. So we can know this solution is correct. If we do like this, very, very close, very, very small value, and done, even though we can, the solution is false. So because, do you know why this one is happening? If I use the help command, MR inverse kinematics body, then here we can know the next iteration is limited as 20. So if the iteration value is over 20, it generates false in return false. So because we gave too small value in here, they returned first. How about this one? Oh, it's too small. How about this one? Oh, it's also too small. Then it is true. So if you want to increase this one, you can modify this value in the source code, but there is no option to change the iteration value. So in the next class, I will introduce about the numerical inverse kinematics using symbolic modern robotics library. In this class, I only showed the numerical inverse kinematics using modern robotics library, but if you see the result using symbolic modern robotics library, it will be more helpful. Okay, today's class is over. So let's finish today's class. And okay, today's class activity will be okay, I will give some exercise. So let me find some solve analytical numerical solve inverse kinematics. You do not need this intention. Okay, where is proper use lepton method iteration finding to okay. I will give you some example. Okay, this one. Exercise 6.9 will be proper problem. So using inverse kinematics body, you can find goal configuration corresponding to this one. Okay. This one will be your class activity, and by using modern robotics library, you should practice about this one. Okay, today's class is over. See you next time.